Welcome to Cool Time, a show about air conditioning. I'm Matt, and these are my co-hosts, Scott and Larry.
You know, despite all the changes taking place in the industry, mobile air conditioning is a very profitable venture, and chances are it's going to get even more profitable.
That's right, Scott. Over the next few years, we're going to see more changes than we've seen in the last 20. Government regulations and SAE standards are going to set the stage for a new era of AC service.
These regulations, retrofits, conversions, and new system designs all play a big part in our future. And for those of us who provide professional AC service, there's going to be increased profit opportunity. And speaking of profitable opportunity, take a look at this.
Wow, that looks like an egg-shaped car, Matt.
It sure does. And while egg-shaped cars like the Mazda MX-3, Ford Taurus, or Chrysler LHS get good gas mileage, they don't circulate much air, even with the windows open. In fact, cars like these get better mileage with the windows closed.
That's why 93% of the domestic cars on the road today have factory-installed air conditioning. How's that for profit potential?
Pretty darn good. But as many of you know, scientists have linked Freon, R12, to ozone depletion. So today, more and more mobile air conditioners come already equipped with an environmentally friendly refrigerant, R134A.
That's right. And despite everything you've heard, we believe servicing these vehicles won't be much different than it is right now.
And that's what this program is all about. In the next few minutes, we're going to review the fundamentals of air conditioning.
And we'll highlight the differences between R12 and R134A systems so you can see how similar they really are.
All right, guys, what do you say? On with the show?
Take it away.
Boy, it's hot in here. I got the sun coming through the windows and roof, the heat reflecting off the road, and the heat from parts like the exhaust and engine. Good thing I got my air conditioner. See, the air conditioner doesn't just blow cold air. It picks up heat from inside the car, carries it outside, and releases it. And to do this, it needs a substance that can move heat quickly and easily. And in most cars and trucks, this substance is called R12 or R134A. In general, R12 and R134A are a lot alike. Both are non-flammable, harmless to AC parts, and transfer heat quickly and easily. Plus, R12 is non-corrosive, except when it mixes with water. But there are some important differences that keep you from using one in place of the other. The most important is R12 mixes with mineral oil, and R134A doesn't. So in systems using R134A, you've got to use synthetic oils, like PAG or ester. Most OEM manufacturers use PAG oil in their R134A systems, and they recommend it for R134A conversions. Others recommend ester oils. Now, we recommend ester oil with system conversions. You'll find details on the instruction sheet that comes with your compressor. Another thing you need to know about air conditioning is that as pressure increases, so does temperature. In other words, the harder you squeeze something, the warmer it gets. And air conditioning systems use pressure to help transfer heat. Fortunately, when it comes to pressure, R12 and R134A are a lot alike. For example, at 32 degrees, both refrigerants exert about 30 pounds per square inch. And that means diagnosing and servicing these systems is similar. But the real key to understanding just about any mobile AC system is this. Heat always flows from a warm area to a cool one. Just like water always runs downhill, heat always flows from warm to cool. So as R12 or R134A evaporates or changes from a cold liquid to a cool gas, it picks up heat from the air around it. In other words, the cold liquid in the air conditioner absorbs the heat from the warm air in your car. And this happens at the evaporator near the passenger compartment. Likewise, when R12 or R134A condenses or changes from a hot gas to a hot liquid, it lets heat go. In other words, the hot gas releases its heat to the cold outside air. And this happens at the condenser at the front of the car, in the airflow of the fan. This is how the air conditioner takes the heat out of the car so you and your customers stay nice and cool. Back to you, Scott.
Thank you, Larry. As you can see, I've assembled some air conditioning system components here so that you can see what they look like. When you understand what these components do, it's easier to troubleshoot the whole system. Now, as you can see, a typical system contains a compressor to move refrigerant through the system, a condenser to remove heat to the outside air, a receiver dryer to remove moisture and dirt, an expansion control valve to regulate flow and pressure, and an evaporator to remove heat from the passenger compartment. Now, let's take a look at how all these components work together in your car or truck. The heart of any air conditioning system is the compressor, and like your heart pumps blood, the compressor pumps refrigerant. Simply put, the compressor takes cool refrigerant vapor from the evaporator, puts it under pressure, and forces it through the system to the condenser. And remember, increasing pressure increases temperature, so the compressed refrigerant also gets hot. In the condenser, moving air at the front of the car cools the hot gas, condensing it into a hot, high-pressure liquid. From there, it moves through the dryer to the expansion control valve, which relieves the pressure and cools the liquid even further. At the evaporator, the cool refrigerant absorbs the heat from the passenger compartment, starting the cycle over again. One last fact, the AC system has two sides, a high-pressure side from the compressor to the expansion valve, and a low-pressure side from the expansion valve to the compressor.
Oh, what do you have here, Scott?
Well, this is a drawing of a Harrison HR6 axial compressor made by General Motors, Matt.
Yeah, well, it looks complicated, but how's it work?
Well, compressors like the HR6 use pistons to move refrigerant and reed valves to control flow. So when the piston goes down, it draws refrigerant through the suction reed valve into the chamber. Then when the piston goes back up, it compresses the gas and forces it through the discharge reed valve into the condenser. Now, the important thing to remember is these reed valves are made of lightweight spring steel, so if you don't recharge the system properly, well, you can damage or break the valves.
You mean like liquid charging with the engine running or something like that, right?
Exactly. And remember, oil is the lifeblood of your AC system, so whenever you replace a compressor, always use fresh oil. And follow the procedures in your shop manual or instruction sheet. Now, we'll be showing you specific oil replacement guidelines later in this program.
Okay, that's neat. By the way, this is an axial compressor, right?
Right, and what that means is that the pistons run lengthwise, parallel to the crankshaft. Now, other designs include the radial compressor, where the pistons are arranged like spokes on a wheel around the crankshaft. The variable displacement compressor, which pumps more or less refrigerant without cycling on and off. The scroll compressor, which doesn't have any pistons and works like a swirling tornado to pump refrigerant and create pressure. And the rotary vane compressor, where centrifugal force seals the vanes against the side of the housing as a rotor turns.
Two other compressor components are the field coil and the belt-driven clutch. When the field coil gets the voltage from the switch or relay, it magnetizes the pulley assembly and clutch shoe and starts the compressor turning.
You know what this is, Matt?
No, what is that, Scott?
That's an O-ring.
Yeah, you're just saying that because it's shaped like an O.
Well, it is, but the important thing about O-rings is that R134A systems need special ones. Now, you know what else is important about this O-ring?
Oh, yes, I do.
Oh, good. What?
It's round.
No, it's blue. And that means it's rated for R134A and can be used with R134A or R12 systems.
Okay, well, now that is important, Scott.
Very important.
And, Scott, it's also important to know that all the replacement compressors we currently produce are fitted with O-rings rated for R134A. So when you've got the right compressor for the job, you can use it with R12 or R134A. So I'm kind of burned out on compressors. How about you?
After the refrigerant leaves the compressor, it travels through the discharge line to the condenser, where it releases the heat from the passenger compartment. That's why most manufacturers put the condenser in front of the radiator, where it gets a lot of moving air. And because R134A is less efficient, these systems use a special cross-flow condenser, which moves more heat faster. Also, when converting to R134A, you may need a cooling fan to control high side pressure. For the most part, condensers are pretty trouble-free. But you do need to check for cracked tubing and loose fittings. And you need to check for internal restrictions or cooling system problems that can lead to poor performance. But in reality, most condenser problems are caused by airflow restrictions blocking the condenser coils. Now, on the passenger side, we find the evaporator, where the refrigerant picks up the heat from inside the car. Here again, you've got to check for loose fittings, cracks, and leaks. And remember, as heat is absorbed, water forms on the fins, and a lot of dirt and dust clings to this water. So once again, you've got to check for dirt and grime and airflow restrictions of all kinds. And be sure to check the evaporator case drain. Plugged drains can cause water damage and some very unpleasant odors.
Now let's talk about two common AC system designs, the expansion valve and the fixed orifice tube. In the expansion valve system, a special valve monitors pressure and temperature and controls refrigerant to the evaporator. To do this, a gas-filled sensing bulb is clamped to the evaporator outlet, covered with insulating tape, and connected to the valve by a capillary tube. As the temperature of the refrigerant leaving the evaporator goes up, the gas in the bulb expands. This pushes the gas through the tube, which pushes a diaphragm and opens the valve, letting in more refrigerant. As the refrigerant leaving the evaporator cools the sensing bulb, the gas in the bulb contracts and closes the valve. This back and forth process controls the refrigerant to the evaporator, producing the optimum temperature. Remember, expansion valves are made for specific air conditioners, so when you service or replace it, make sure you use the right one. Also, when you service the system, remember to clean or replace the expansion valve inlet screen if it has one. Failure to do so could cause future service problems. In the expansion valve system, somewhere in the liquid line between the condenser and the expansion valve, you'll find the receiver dryer, which stores, filters, and removes moisture from the liquid refrigerant. The receiver part stores liquid refrigerant and makes sure that the expansion valve always has a constant supply. The dryer part is a bag filled with moisture-absorbing material called desiccant. Finally, a screen prevents dirt from plugging the expansion valve. If the screen gets dirty, refrigerant and oil can't pass through, causing part failure and poor performance. That's why it's important to replace the receiver dryer whenever you work on the air conditioning system. In fact, when you're replacing a compressor, your compressor warranty depends on it. Remember, receiver dryers are like oil filters. You can't reuse them. They must be replaced. Now, the second kind of air conditioning system is the fixed orifice tube design.
Matt here with a nifty invention called the orifice tube. Well, actually, it's not so nifty. In fact, it's just a tube. In this system, the orifice tube replaces the expansion valve, and a part called the accumulator replaces the receiver dryer. So the system ends up looking something like this. The diameter of the orifice tube controls the amount of refrigerant that can flow to the evaporator. This tube is also the main filter for the whole system, so always check to make sure that it's not plugged. Now, on many GM cars, if the orifice tube breaks in half and you can't get it out, a special repair kit lets you get around the problem without replacing the evaporator. Also, GM has two kinds of orifice tubes, and even though they look the same, the way they fit in the system is different, so be careful. Unlike GM, Ford uses a lot of different orifice tubes, so before you work on any Ford air conditioner, check the catalog or manual to make sure you've got the right tube. Plus, on many Fords, the orifice tube is permanently crimped into the liquid refrigerant line. To replace it, you've got to replace the entire line, or use a repair kit. And once again, when you replace the compressor, you've got to replace the orifice tube to receive the compressor warranty. Now, since 1980, Ford systems have used spring locks to connect AC lines to the AC parts. These connectors snap together and use two O-rings to seal the line instead of the usual screw-together fittings. Now, over time, these connections can leak. To fix it, you need special tools, and we recommend green O-rings. Plus, you may need to clean the inside of the female tube with emery paper. We also offer a repair kit to help prevent the leak from reoccurring. Now, since an orifice tube can't actually close like a valve, it is possible for liquid refrigerant to get past the evaporator and damage the compressor. But the accumulator located between the evaporator and the compressor stops this from happening by collecting liquid refrigerant and only letting oil and the vaporized refrigerant past. Plus, like a receiver dryer, the accumulator uses desiccant to dry the refrigerant. So replace the accumulator whenever you replace a major air conditioning component. And don't forget, you must replace the accumulator when you replace the compressor to receive your warranty. Also, we now use Desiccant XH7 in all our replacement accumulators, which is compatible with both R12 and R134A.
In automotive AC systems, the main cause of refrigerant leaks is hose. So when refrigerant charges started getting smaller and warranties started getting bigger, it just made sense for manufacturers to start using better hose materials. So in the late 80s, manufacturers gradually switched over from rubber to the new barrier type hose, which is exactly what's needed for the ozone-friendly R134A. The switch to R134A also means that you'll need barrel or bubble crimps like these instead of surface crimps like these. And when you're using R134A, remember to use R134A compatible O-rings. Finally, in 1990, GM began using sealing washers at the manifold instead of O-rings. Now, this has virtually eliminated leaks at the manifold. And remember, never use oil when you're installing a GM sealing washer.
Stand back.
Stand back is right. You've really done it this time, Matt. That's the worst case of evaporator freeze-up I've ever seen.
I figure it's probably just a stuck valve or switch.
Good guess. Now, obviously, we're exaggerating here, but the point is that if the evaporator gets too cold, the water that collects on its surface freezes, blocking the flow of air. Now, to keep this from happening, manufacturers control the temperature of the evaporator with valves and switches. For example, on some older GM cars and trucks, this POA, or pilot-operated absolute valve, senses the pressure in the evaporator, and when it gets too low, reduces the flow of refrigerant to the compressor, which increases pressure in the evaporator.
And you know what that means. An evaporator temperature that hovers around 32 degrees.
Right, ice-free, Matt.
Ice-free.
Now, this valve, or one like it, is also used in a lot of older Fords, Chryslers, or imported cars, where it's called an STV, an ETR, or EPR valve.
Okay, well, Scott, what about this thing right here? This looks like, I don't know, something out of my stereo or something.
Well, that's a thermostatic switch, Matt, and that's another way that manufacturers control evaporator temperature. The thermostatic cycling switch has a gas-filled capillary tube, just like the expansion valve. As the evaporator core gets colder, the gas in the tube compresses, which opens the switch and stops the compressor.
Cool.
And when the evaporator heats up, the gas in the tube expands, closing the circuit and starting the compressor.
Real cool.
Right. You know, thermostatic control switches actually help improve gas mileage because the compressor only runs when the system needs it.
Well, another way manufacturers stop freezing is with this, a pressure clutch cycling switch. Now, basically, it acts like a thermostatic switch, except it measures pressure. This switch also protects the system if the refrigerant runs low, and it protects it if you want to run it when it's really cold outside. To find the pressure cycling switch, look on the suction line or the accumulator.
Right. And remember, these switches can be hooked to the engine or powertrain control module that controls the compressor clutch, so you may want to check the service manual. One last switch is the solid-state thermistor, or electronic clutch control switch. Now, with this switch, resistance changes with the temperature and signals a control module that turns the compressor clutch on and off. And depending on the make and year, you'll find this switch in the suction line, in the evaporator fins, or the thermal expansion valve.
Which is why you probably will want to check your manual. Man, am I glad we're done with that. I mean, how many ways can you keep your evaporator from freezing? You've got your POA valve, your STV valves, EPR valves, ETR valves, thermostatic switches, pressure clutch, cycling switches, thermistors.
And variable displacement compressors, Matt. This little beauty is the latest in pressure temperature control technology. It actually adjusts its output to match the heat load of the evaporator. And that means cool air in the passenger compartment and a smoother running engine. You'll find variable displacement compressors in late model GM, Chrysler, Infiniti, Toyota, and Subaru cars and trucks. So if the system you're working on doesn't have valves and switches, you're probably looking at a variable displacement compressor.
Oh, hi there. I'm just sitting here relaxing, thinking about AC system protection switches. These switches come in all shapes and sizes, and they usually open the compressor clutch circuit if the system pressure gets too high or too low due to a component malfunction. Every system has one or more of these switches, and to find them, consult your manual.
Now let's talk about fans. In recent years, electric radiator fans have gotten very popular because they draw less power than belt-driven fans, and they help control emissions. But the main reason manufacturers like them is they work with transverse-mounted engines. The important thing to remember about these fans is that they work together with the car's computer module, air conditioning system, and driveline inputs to keep things cool. So it's not just your basic fan. If something goes wrong, check the manual. The same goes for almost all the systems in your late model cars and trucks. Computers are everywhere, and the right approach is the systems approach. AC problems can easily be related to drivability and powertrain control systems. So it's a good idea to check the stored codes and to use your scan tools, your digital voltmeter, and your manual.
Well, that just about wraps it up for part one of our show on air conditioning.
And I know I'm worn out.
Any last thoughts?
Just want to say this is Matt, reminding you to be cool, and remember the best time is cool time.
Hi, welcome to Cool Time, a show about air conditioning.
In this program, we'll give you a 4-step process you can use to diagnose mobile air conditioning problems.
And we'll show you a few service procedures you'll need to do to repair these systems. But first, let's talk about tools.
Right, Scott. In this business, you can't be cool without the right tool. And the right tool is right here. The manifold gauge set, the single most important tool you'll need for troubleshooting and repairing automotive air conditioning systems.
Matt's right. As an AC service technician, you'll use your gauge set to check operating pressure and to recover, evacuate, and recharge air conditioning systems.
Plus, in today's market, you actually need 2 sets, one for R12 and one for R134A.
As you can see, a typical gauge set has a high side gauge to measure pressure, a compound gauge to measure pressure or vacuum on the low pressure side, a manifold with 2 hand valves, and a set of hoses.
And remember, to be legal, all hoses must have hand shutoff or anti-blowback valves within 12 inches of the end.
Right. Now, to check operating pressure, make sure both valves are closed, because opening a valve opens that side of the system to the center hose.
Great, Scott. Here, now let me show you how to hook this baby up. Come on.
Wait a minute, Matt. You're going to need...
Okay, Scott. Hooking up this gauge set is simple, all right? It's so simple, my dog could do it. You just screw the low pressure hose on the low side, like so. Then you screw the high pressure hose on the high side, just like this. Okay, hold on one second.
Matt, this is an R12 system. On most R12 systems, the Schrader fitting on the high side is smaller. So in order to attach the hose, you'll need one of a variety of fittings like this one.
I knew that.
The good news is that unlike R12, R134A fittings are all the same size. So when you work on R134A, you only need one set of fittings.
And I knew that too. Hey, welcome back to Cool Time.
They never left, man.
Oh, yeah. Right. Hey, speaking of Wright, here's Terry Wright, AC
Terry,
technician and instructor with 12 years of experience. Thanks for being on the show, Terry.
Hey, my pleasure.
We asked you here to talk about leaks because we figure you've seen a few leaks in your day.
I sure have, Matt. And you know, even though nylon barrier hose has become the norm, 75% of AC problems is attributed to leaks. And 35% of these leaks are caused by the hoses or hose fittings.
Let's face it, no matter how strong the manufacturers make the hoses, most of us are putting 20, 25,000 miles a year on our cars, and that kind of wear is bound to cause leaks.
That's a good point, Scott.
Well, let's take a look at a few ways that we can find leaks.
Works for me.
All right.
Over here, we have an electronic leak detector.
That's right, Matt. And as you know, the Society of Automotive Engineers has developed criteria concerning the sensitivity of electronic leak detectors.
Now, that'd be criteria J1627, right, Terry?
That's right, Matt.
And while the federal government has not passed any laws requiring detectors to meet this criteria, some local regulations may be more strict. To protect yourself, look for the label that reads Design Certified to meet SAE J1627 when you buy the detector. And remember, you'll only find this label on detectors made after June of 1993, even though many detectors made before that actually do meet the standard.
Right you are, Matt. And when you check for leaks, make sure that you check all fittings and connections. Hold the probe about 1/4 of an inch away and move it 1 to 2 inches per second along the length of the hose. Now, it's particularly important when you check the fittings that you check all the way around. This meets SAE standard J1628 procedures for using electronic leak detectors.
One other product you'll want to know about is a blacklight leak detection system. What you do is introduce an inert chemical into the system with a special infuser. Now, this dye shows up very clearly under a black light. So, to find a leak, you infuse the dye, run the system, get out your trusty black light, and look the entire system over for the leak. You know, I'd like to start this section with a question, if it's okay with you, Scott.
Fine with me, Matt. I think I can pretty well handle any AC question you can dish out.
Okay, what would you say is your air conditioner's biggest enemy?
Too easy, Matt. The answer to that one is moisture.
I'm sorry, what?
Moisture, Matt. Moisture is the major enemy of any AC system.
Yeah, but that's not really very specific. What are you really trying to say?
Not specific? What's not specific about it? It's water, Matt. Water.
You're right, Scott. Water is the major enemy of your air conditioner. And when you open it to the atmosphere, the humidity or moisture gets into the system and it just starts to destroy it. In older systems, water combines with R12 to form hydrochloric acid, which attacks the metal parts. And with R134 systems, water breaks down the oil, causing components to fail. Finally, water can gather at the expansion valve, freeze, and block the flow of refrigerant, causing poor performance or worse.
Matt's right, you know. So to dry out your system, use a vacuum pump like this one. Since water boils at a lower temperature in a vacuum, the vacuum pump helps dry the system by lowering the pressure to the point where it turns to steam and is pumped out with the air. Before you work on any system, though, remember, you've got to have your refrigerant recovery and recycling certification. Since November 15th, 1994, no one can buy refrigerant without it. Remember, too, that by law, your shop has to own and use refrigerant recovery and recycling equipment. Check the appropriate federal and state regulations.
That's a good point, Scott. And when you buy recovery or recycling equipment, make sure it's UL listed and registered with the EPA.
What's going on, Matt?
Not much. I'm recharging your sister's air conditioner, and as you can see, I am doing it right.
That's right. As you can see, Matt's wearing his safety glasses, working in a well-ventilated area, and he's definitely not smoking. Also, Matt's using an accurate scale to charge the air conditioner by weight. That's because modern AC systems use a lot less refrigerant than your older ones, and half a pound one way or the other can make a big difference in the way the system performs. Other measurement systems include the dial-a-charge system and automated charging systems. Hey, Matt, what's this refrigerant you're using? I never heard of Uncle Bob's refrigerant blend.
No problem. That's one of those new Wonder refrigerants.
No, Matt, stop this second. Seriously, folks, non-approved refrigerants can be extremely dangerous. Please use R12 in R12 systems and R134A in R134A systems.
Scott, would you just relax? I don't generally use this stuff. I just thought that I'd try it out this...
Hi, welcome back. It's great to be with you.
Yeah, say that again.
We'd like to welcome back our co-host from Part 1, Larry Reynolds.
Hey, guys, it's great to be here.
Yeah. Well, in this part of the program, we're going to talk about the most important part of the customer service process, the diagnosis.
That's right, man. Because if you don't diagnose a problem right, you can't fix it. And that leads to unhappy customers.
So to help keep your customers smiling, we recommend a 4-part diagnostic process. Get the facts, do an external check, do an internal check, and run a performance test. And to make sure you cover all the bases, we recommend a comprehensive checklist. To get a copy, contact your AC distributor or make your own.
Now, to show you how a true professional handles a diagnostic process, we've stationed our cool-time cameras outside of Terry Wright's service bay. Uh-oh, looks like a customer's coming. Let's watch old Terry spring into action.
Yep, there he goes. And the first thing he's going to do is get the facts from the customer.
That's right, Matt. Now, he's got his checklist, and it looks like he's trying to nail down the exact nature of the problem.
Right, Larry. He's probably asking about air temperature, time of day, airflow, you name it.
Yeah, right.
Anything that helps him pinpoint the problem, because an accurate description helps him figure out if the problem's electrical, mechanical, or related to refrigerant.
Okay, it looks like he's in the office
There he
now.
goes.
Yeah. All right. Hey, he's in the office. He's typing on a computer.
Right, Matt. He's looking through his records to see when the system was last serviced. This can give him valuable information to help solve the problem, reduce repair time, and satisfy the customer.
Okay.
Yeah. Oh, look. It looks like he's found what he needed, and he's heading back to the service bay.
There he goes.
Now, wait a minute.
What happened? What is that?
We lost the picture. What do we do now?
Nothing, Larry. You just go out and talk to him. That's why you get paid the big
What?
bucks.
You mean just go out and talk to him?
Yeah.
Well, what am I going to say?
Well, ask him about step 2. Come on, get out there and talk to him.
Go,
will you?
man.
Okay, I'm going. Fix it. Hey, Terry, what's happening?
Hey, Larry, not much. Just getting ready to do the second step of my diagnostic procedure. That's the external check.
Oh, that sounds interesting. Hey, mind if I tag along?
Not at all. Let's go.
All right.
Well, as you know, Larry, once I get the facts, I come under the hood and I check out the engine compartment. I start at the compressor and I look for loose bolts, broken brackets, frayed wiring. Then I just circle the whole system.
As Terry circles the system, notice he checks the drive belt for wear or improper tension and alignment, checks the condenser for airflow restrictions, and checks the cooling system, making sure there's enough coolant and that everything's working right. After all, the cooling system directly affects AC performance. Then he checks the fan. If there's a thermostatic fan clutch, he looks for smooth rotation, too much play, and leaks at the bearing. On electric fans, he looks for tight bearings or loose electrical connections. Plus, he usually does an amp test to make sure the fan's not pulling too much current. Then he moves inside the car. Here, Terry starts the engine and moves the selector through the airflow settings. If there's a problem, he'll check the vacuum source, motors, and selector switch. Then he checks the temperature control, feeling the air to make sure it's the right temperature. Finally, Terry checks the blower motor, completing his external diagnostic check.
Hi, Scott here to review the third step in the diagnostic process, the internal check. Basically, what I'm going to do is start at the compressor and work my way around the system using my ears, eyes, and hands to check for broken parts or restrictions. Now, starting at the compressor, the first thing I'll do is check for knocking or grinding that indicates there may be a problem with the compressor or the compressor clutch. And while I'm here, I'll also check for proper coil voltage. Now, if everything's okay, the next thing I'll do is run my hand along the discharge line from the compressor. Now, when I do this, I'm very careful because this line can get hot. Here, I'm checking for changes in temperature that tell me the line is blocked and may need to be replaced. Now, if everything's okay, the next thing I'll do is run my hand along the condenser from top to bottom or along the return bend. And here, what I'm checking for is a gradual change in temperature from hot to warm as I move from top to bottom. Now, if I see any frost spurts or feel abrupt temperature change, I may need to clean or replace the condenser. Next, I'll check the liquid line from the condenser. Now, unless I'm checking a fixed orifice tube system, the line should be warm along its entire length. And here again, frost rings or changes in temperature indicate that the line is blocked. In a fixed orifice tube system, the tube can be anywhere in the line from the condenser to the evaporator. The line should be warm on the inlet side of the tube and cold on the outlet side. Now, if the system has a receiver dryer, I check that next. The inlet and outlet lines should be about the same temperature, and if there's frost on the lines or the tank, I know it needs to be replaced. Next, I check the sight glass if it has one. If it's clear and there's some cooling, it usually means the system's fully charged. If it's clear and there's no cooling, that generally means it's empty. If I see bubbles, it's low on refrigerant. And if the glass is brown or gray, the desiccant may be loose in the system. Next, if I can, I carefully check the expansion valve. Unfortunately, in many cases, you can't get to it, so you have to check it indirectly with your gauge. But if it is accessible, I look for sharp temperature changes between the inlet and outlet to tell me it's working. If I see frost on the inlet, that indicates the line may be restricted. Finally, I feel along the suction line to the compressor. Now, this line should be cool to the touch, but if it's covered with frost, that may indicate that the valve is stuck open and flooding the evaporator. Now, on fixed tube systems, I pay special attention to the orifice tube. If I find frost in front of the crimp dimple on the high pressure side, that indicates the tube is restricted and needs to be replaced. Also, it may mean that you need an inline filter. Now, also on fixed orifice tube systems, the evaporator outlet, the accumulator, and the suction line should be cool to the touch. Any change in temperature means the line's restricted.
Hi, Matt back with you, and with me is Master AC Technician Terry Wrong.
That's right, Matt.
Oh, right, I'm wrong. It's Terry Wright. And over by the test car is Scott. In this part of the program, we're going to show you how to conduct the performance test, the last part of the four-step diagnostic process. Now, to conduct this test, we have asked Scott to hook up a manifold gauge, just like you would. And to make sure our readings are accurate, we've set the car to the manufacturer's recommended test standards, and we've carefully followed the recommended procedures.
Very good, Matt. A lot of technicians tend to skip these procedures. However, in order to ensure accurate results, it's very important to do the job right.
Well, as always, you're right, Terry. This time I mean correct. And to maintain engine speed at the correct RPM, Scott's hooked our test auto to the official Cool Time Scan tool. Now, for this part of the program, Scott's going to simulate some typical readings you might see in a routine test. And based on those readings, Terry will give us a probable diagnosis or some things to look for. Are you ready?
I'm ready.
Okay. In the first reading, the low side or compound gauge reads about 30 and the high side reads 170. According to the manual, that's normal, but the air conditioner barely works. So what do you say, Terry?
That's a tough one, Matt. But in this case, I check for problems outside the AC system, like vacuum or electrical system problems, or problems with the automatic temperature control system. So you may want to go back to the external check, or check the service manual for the specific vehicle you're working on.
All right. Well, now that was a tough one, but as we said before, the right approach is usually the systems approach. All right, you ready for the next readings?
I'm ready.
Now, in this case, the low side gauge reads 30, and the high side gauge reads 120. That's low for both sides. So what could this mean, Terry?
When both gauges read low, it usually means low refrigerant. And to make sure, you need to do a static reading. Simply shut off the system, let the pressure equalize, and check your gauges. If there's enough refrigerant in the system to function, both gauges will read within 10 psi of the outside temperature.
Right.
For example, if the garage temperature is 80 degrees, both gauges will read between 70 and 90 psi. You'll also get low readings if the expansion valve or orifice tube is plugged, or if the expansion valve is stuck closed. In this case, look for frost to build up on the inlet of the expansion valve or orifice tube, and for the clutch to cycle on for a few seconds and then off for a long period of time.
Okay, let's look at another set of readings. We've speeded up the action here, but in this reading, the gauges start out normal and gradually drop over a period of several minutes. So what does this tell you?
This says there's a restriction on the high pressure side of the system. The readings start out normal because refrigerant's available, but eventually it gets bound up. And since you can't pump what you don't have, the pressure drops. Here you want to recheck the high side, looking for temperature variations and frost spots.
Right, and that can actually look like a low refrigerant charge, couldn't it?
Exactly, which is why it's very important to do both your internal and your external checks.
Okay, in the next example, the high side gauge reads 375 and the low side gauge reads 60. Both gauges read high.
That's a classic overcharge problem, and it may take 10 to 15 minutes to show up. Plus the discharge line and the condenser will be hot to the touch.
Now remember, modern systems use less refrigerants than older systems, so accurate recharging is a must.
That's right. Other problems that can cause high gauge readings are airflow restrictions and stuck open expansion valves. For airflow restrictions, check the condenser, the fan clutch, the fan motor, and the cooling system. For a stuck expansion valve, look for moisture on the suction or low pressure lines.
Okay, good. Now one last example. In this case, both gauges read about the same. The high side is low and the low side is high. So what's that mean?
It could be a stuck variable displacement compressor, or it means you've got a shot compressor. And compressors usually fail for one of two reasons: broken piston rings or busted reed valves.
Gotcha, Terry. Good. And these problems are usually caused by things like the wrong oil or refrigerant, too little oil or refrigerant, contaminated oil or refrigerant, and improper charging.
Right, Matt. That's why it's important to know and follow the recommended service procedures when working on AC systems.
Thank you very much, Terry. That completes the four-step diagnostic process. Now, once again, the four steps are: get the facts, do an external check, do an internal check, and do a performance test. Anything else?
Use a checklist. Make sure you've considered all the possibilities, review your facts, and then make your diagnosis.
It's good advice. Oh, hi. In this next part of the program, we want to show you some basic service operations you'll need to perform. But before we get started, we'd like to talk to you about money.
Hey, we know the situation's changed out there. Air conditioning isn't just a gas and go operation anymore. Today, it's illegal to vent CFC refrigerants into the air, and soon you're going to have to recover and recycle R-134a.
But still, these regulations protect the environment and really do make sense for everyone. On the other hand, these changes are going to cost money. Money you're going to have to pass on to your customers. But extra costs mean extra profits. And for those of you who stick with it, the chance exists to earn more AC service money than ever.
Plus, as you've probably figured out by now, maintaining these systems and complying with the laws isn't going to be much different than it is right now.
So let's move on to the next part of the show, where we're going to talk about service.
Before you open an AC system to the air, you need to remove the refrigerant. And to do that, you need a UL-approved recovery machine. You also need to be CFC trained and certified. And don't forget, the fines for not following these laws can be high. So get your certification, do the job right. Getting all the refrigerant out of the system can be tough, especially from the accumulator or receiver dryer. So if you need to, use an electric heat gun to warm those parts and vaporize the refrigerant. But remember, never use an open flame. That can cause poisonous gases or an explosion. Once you've recovered all the refrigerant, make the repairs. But don't forget, if you're working on a fixed tube system, no matter what kind of repairs you're making, check the tube. If it looks like this, replace it. Most manufacturers recommend an inline filter. When you install it, be sure to check your catalog and see if it comes with a built-in orifice tube. Now, because replacing a compressor is critical, let's take a few minutes and review that procedure. Understand from the beginning, when you replace a compressor, you must replace the receiver dryer or accumulator to receive your warranty. Also, check and replace the orifice tube if needed on these systems. On expansion valve systems, you should clean or replace the expansion valve screen if it has one. Finally, we recommend you install an inline filter or flush the system using industry-approved procedures. And remember, the old way of flushing, venting R11 or R113 into the air, is illegal. These simple steps minimize the risk of compressor failure due to system contamination. And as every AC professional knows, the only good system is a clean system. Now, let's take a look at the replacement procedure. After the system is discharged and you've disconnected the battery ground, take out the old compressor. And when you do, be careful not to spill the refrigerant oil. Instead, drain it into a measuring cup and write down how much was there. Then, drain the oil from the new compressor into a clean container. This lets you adjust the amount of oil in the new compressor to the amount left in the old one and keeps you from adding too much oil. Next, read the directions that come with the compressor and add the recommended amount of oil. And don't forget, for R12 systems, use mineral oil. For R134A systems, use the type of oil recommended by the manufacturer. Then, do the same for the accumulator or receiver dryer. Consult the directions and add the recommended amount of oil. Next, install the compressor, reusing the switches and replacing any broken ones. And attach the hoses using new O-rings and seals. Lubricate the O-rings with mineral oil, and remember, if the car or truck uses sealing washers or steel gaskets, no oil is needed. With everything in place, turn the compressor shaft at least 10 times. This clears the oil from the cylinders. Skipping this step can lock up the compressor and void your warranty. Next, attach the drive belts using your tension gauge to adjust them to the recommended specifications.
Hi, Matt here. Reminding you that when everything is back together, you need to remove the air and the moisture. And to do that, you need to evacuate the system. To begin, hook up your manifold gauge set and with the hand valves closed, connect the center hose to the pump and turn it on. Then open the low side valve to open the low pressure side of the system to the pump and watch the high side gauge. When the pressure drops, you know the system is free and clear and you don't have any restrictions. Next, open the high side valve and evacuate for 10 minutes. When you're done, the low side gauge should read 29 inches of vacuum. Now, if you're working above sea level, subtract 1 inch of vacuum for every 1,000 feet. And finally, close both gauges and wait 5 minutes. If the system loses less than 1 inch of vacuum, you know it's sealed to the outside air. So, back to you, Scott.
Thanks, Matt. After evacuating the system, I recommend adding a pound of refrigerant and then checking for leaks. This is because some AC systems don't leak under vacuum. They leak under pressure, and this prevents you from returning a leaky system to your customer. After installing the test charge, check for leaks, then recover the charge, making sure you get it all. Then evacuate the system for another 30 minutes. When you're done, shut the valves, disconnect the pump, and recharge the system following the recommended procedures. Well, that just about does it for Cool Time.
Thanks for joining us, but before we go, remember, charging a system is one of the most critical service operations you perform.
That's right, so no matter how you measure the refrigerant, make sure you use the right amount.
Remember, a low charge can cause the clutch to cycle too often, leading to poor cooling and excessive clutch wear.
And too much refrigerant can lead to poor performance because of too much liquid in the condenser. Plus, too much refrigerant can cause control switches to work wrong, leading to compressor damage.
But when you do it right, the gauges read the right pressure for the outside temperature, and the air from the vents is cold and sharp.
And most important of all, you've earned yourself another satisfied customer. And that's what it's all about. For Cool Time, I'm Scott.
And I'm Matt, wishing you satisfied customers and lots of air conditioning profits for years to come.
So long.